welcome to this Zoom session, and welcome to the Eagles Robotics Club members. This is the little robot, and we're using servo motors here. And the reason why we're using these is they give you pretty precise control over movements on the robot. The program that's running in here just varies the speed and direction of the motors. So let's just hit the reset button and replay that. And so what we're going to do now, we're just going to switch that off. This Parabotics Eagle Robotics Handbook you can pick up on the website. And so what we're going to do here, we're going to go into the shared screen, and we're going to have a look at this screen quickly. This is a very nice little robot that we've been working on and designing. So there's our proto board, which is on top of the battery holder. We've reduced the parts count, and that is to make the exercise, make it more affordable to participate. So look out for this design. We'll show you how to design this thing in future sessions. Today we're just going to focus on understanding robot movements. You can download this off the website, and if we page along here and we go to workshop number 2, so workshop number 2 in the Eagles Parabotics book. This is really simple stuff. It's 4 lines, 5 lines, 10 lines of code, so it's a nice, easy way to learn. This is a very short little program, and you'll see here, this is an oscilloscope trace. These lines of code here generate this square wave pattern that you see over there. And the purpose of this is to control these little motors, because these are hobby servos. These are continuous rotation hobby servos. And there's a little board in here that controls a DC motor, which has a gearbox. And what happens is if you send varying pulses into these motors, it activates the motors, and that's how they work. I thought I would just type up this program, and I'll type it with some errors, and then we'll try and upload it into the robot, and then you'll see an error message, and then we'll show you how to look for errors in your code. Now what you should see on your screen, this is Arduino Code, so let's slightly enlarge that. This is a demonstration of motor functions, and we're going to come back to this code, but what we're going to do here is we're going to click on File and then New. So if you look at your screen, you'll see there's really, this is what they call the bare minimum of code. Without this code, you'll definitely get an error message when you try and upload to the robot. So there's no actual code in this code. This is just a framework, and you can in fact upload this to your robots. If your robot looks like this robot, there's a few things you need to remember. One of the things you need to remember is if your robot is switched off, you're not going to be able to upload a program to this chip because this chip is switched off. Now, there is a solder pad on the back of this board here that you could put a blob of solder in there on that solder pad. If you bridge over those solder pads, you would, in fact, be able to power the chip off your USB port off your computer, but that's not a good idea, really. So rather leave that out. And then just remember, when you're ready to download a program to your robot, just switch on the main power switch. And now you can upload any program, even a blank program, into the chip. So let's go back there. So now what you can see is you've got the minimum to not generate an error message. We just go here and we just check that COM7 is active. That little check mark there shows it's active. And you've selected an Arduino Uno. And when you press upload, you will see down here, you will see there's a progress bar indicator. It compiles the sketch and then it uploads the sketch. And we're getting an error, not sure why. So let's have another try here and see. Then let's try again. So that went through. It says done uploading here, and that has completed. If we go back to the robot here, if we switch on the motors, we hit the reset button, nothing happens because there's no code there. So let's see what this is, our demo of motor functions. Okay, so this is a bit more complicated. You'll see up at the top there, you've got a library that it refers to. You've got a whole bunch of stuff here, so we'll come back to this. And here you've got motor moves all grouped at the bottom. And this is a demonstration of motor functions, which in the C++ language, it's a function. If you were learned to program back in the day in BASIC, you would call that a subroutine. So let's just try uploading this into the robot and see what happens. So over there, you'll see the progress bar. It says compiling, uploading, and it says done uploading. And you'll see if I go out here and if I do that again, so let's just go here to this one, demo motor functions. So I'm going to download this again while you're watching the robot. You'll see those little lights are flickering. And then you'll hear the motors spring into life. The reason why the motors come to life like that is because you've put some actual code in between those function lines over there. We are back here. Right, so what you're seeing on your screen is the bare minimum of, so if I go new and do that, this is what happens. You never really have a completely blank screen like that you don't really see that. You can do that and you can type everything out, but it's not really worth it. So let's just go Control Z or Command Z if you're on an Apple Mac. And so you've got two items here. You've got void setup, open and close brackets, and then curly braces and close the curly braces. Your double forward slashes there, that is for a comment. Comments are the way in which programmers talk to each other. So if I write a program that's got 60,000 lines of code in it and somebody else is going to have the misfortune of looking at that code, you can put little clues into your code telling the next person what that line of, or what that group of code lines does, or what that particular line of code does. So that's the function of those. So let's delete them just to make things look a little bit simpler. And you'll see in the void setup, open close brackets, open close curly braces, it says put your setup code here, which runs once. So let's zap that. And then over here, you've got an interesting thing. It's the void loop. And if I highlight on that, it says put your main code here, which runs repeatedly. Most computer programs run in loops because they're constantly checking for a new updated, you might have a state machine that's looking for a status, something like that. So let's just delete that for a moment there. And now what I sometimes do, just a personal thing, I just move that curly braces down there so I can see where the actual code starts and ends. Now, if we come back over here, so I'm just going to, in fact, go Control S to save that. And now it's opening up a little save dialog. And where do I want to save this? Let's go in here and go down here. And let's go to here, whoops, over there. And let's go to Robotics 101 and let's save it there. And we are doing this one today. So let's call this, I'm going to call this pulse, and call this pulse generation. And it's a very simple demonstration, really. So what I'm going to do is you'll see in the loop, we've got these lines of code and it says digital write 10 high, delay microseconds by value, and digital write low. So high and low in many programming languages means to switch a TTL or a CMOS voltage level to high or low, which is basically 5 volts or 0 volts or ground, or in CMOS 3.3 volts or 3.6 volts. So that's basic how you switch things off and on when it comes to digital electronics. So let's type that stuff in, and I thought the reason why I'm going to type it in instead of just cutting and pasting is so that I can put some errors into the code intentionally so that I can show you how you can find your errors. And then we've got this screen here. So what do we need to do at the top there? Well, we actually need to designate a pin. So we go pin mode. Notice we're using bumpy text. So bumpy text is where each new word, where you concatenating words together. So pin mode, that's actually 2 words, but it's written as one. So when we reach the M for mode, we go uppercase. That's called bumpy text. And that's a good practice for you to use, makes your code more readable. And so we're saying pin mode, and in between the brackets we say 10, which is our actual pin, and then we are designating that pin as an output. Notice how the output is all lowercase, and notice when I type things, if I type it wrong, it doesn't come up the right color. So pin mode is it's all black, and that's not right. It's supposed to be orange, but it'll only turn orange if you put in the capital M. And that's a way to help you when you're trying to program and you've been doing it for a while, that you can spot your errors more easily. Essentially, all we've done is we've said that there is a motor connected on pin 10, so we have to select that pin and designate it as an output pin. Now we go down to the loop section of the code, and what we're going to do is we use a command, and we need to go lowercase, so it's digital, and then write. And you probably, if you've learned a little bit about this already, you've probably already spotted an error there, but I'm just going to leave it there because what we're going to see is what happens when we try to upload this to the robot. So I'm littering my code with errors, and for those of you who know about this stuff already, you're probably screaming and getting very excited about these errors that I'm making. So here we do delay microseconds, so you can select whether you're delaying by milliseconds or microseconds, what you're doing. But here we're doing delay microseconds, and there we go, turned orange. That's always a good sign. And so that delay microseconds in this line of code here that I'm just going to quickly highlight, what I'm going to do is I'm going to put a value in there, and this line of code switches on pin 10. Digital pin 10 goes high. Now, how long do we want to keep digital pin 10 high for? Well, that's a function, and I'll talk about servo protocols in a minute, but we know that to make that servo spin nicely, it wants to receive a value of 1300 microseconds or 1.3 milliseconds. That's what we know. The next line of code, we go digital write, and then open and close brackets, and in between those brackets you want to refer to that same pin, and you want to make that pin low. And then here you want to basically introduce a delay value, and you'll see with this delay value, open and close brackets, semicolon, and here we put the number 20. Now when you use the command in the Arduino language, C++, basically, when you say delay, open and close brackets, you put a 20 in there, that's going, the software knows that that's 20 milliseconds. So if you say delay microseconds, it knows it's microseconds, the value in the brackets, but here we just say delay 20, and that's 20 milliseconds or 20,000 microseconds. And now our code is actually complete. So what we can do now, I'm just going to click on save there, and so here's our robot, and if we hit the reset button, basically it's still replaying the code that we've previously uploaded to the robot. So what we're going to do now is we're going to jump out of there and upload this code to the robot, and oops, what happens? We're getting error messages, folks. So notice here it says hi was not declared in the scope, and if you're new to all of this, maybe that doesn't mean too much to you. I'm using the middle wheel of the mouse to scroll around here, and I'm looking at some more detail about this error, and it's got the same message down here. And if we look at this, you'll see it's picking up all sorts of things. And this is the first time you see these error codes. It might be a little bit baffling. You don't really know what this is all about, but it's definitely picked up that there's something going on with that word hi. So if we look up here, you'll see that it's in this version. This is version Arduino 1.8.13 of the IDE. You may be on a different version, which may look slightly different, but mostly the same. But it's taken us to that line of code where it's found an error, and it's highlighted this line in pink. That's not me. And So what's going on here? Well, the fact that it's picked up the word high, if we look at this word high over here, and I just clicked on it, it turned yellow, that should actually be uppercase. So let's try changing that to uppercase and see if that takes away the error codes and lets this program upload. So we type it out high. Now notice how it just quickly turned blue, or turquoise blue there, and that's a good thing, folks. So let's try upload it again and see if this error message doesn't disappear. So we click on upload. Oh dear. So it's still stuck on that line of code, but we fixed this problem. But maybe there's another problem here that we haven't found yet. So, oh dear, look at that. We've got a lowercase w over there. And so let's change that to R. Now notice when I change it to uppercase W, it turned orange. That's a good sign, folks. Now what we want to do is we try to upload. So we, oh my gosh, we are just still stuck on this line of code. So for those of you who know Arduino Code, you're probably screaming out of your minds by now, because guess what? We used a colon instead of a semicolon. So let's try upload again. And this is how you find errors in your code. And if you've got 60,000 lines of code and you're a bit sloppy, you're going to spend a lot of time checking, finding, tracking down errors. But just keep on at it. So now it's moved to the next line. So this line has gone, run through and compiled clear, and it's no longer highlighted. But look, it's highlighted the next line. But what's going on here? Well, you made the same, or I made the same errors we made before. We've got a colon instead of semicolon. And so let's try upload again. And kadum. So that line of code is now clean, but it's picking up on the next line of code, and the next line of code is highlighted pink. And the mistake we made there is the same mistake that we made earlier, which is this needs to be uppercase, not lowercase. So let's fix that. Let's try uploading. And oh my gosh. It's coming through blue, nothing, and the robot's doing something, folks. So let's go have a look at the robots. The wheel is turning, folks. The wheel is turning. So that's all good. So let's go back to the screen here. So essentially, in the loop, let me highlight the loop. There's the loop, folks. So what you're doing is you're switching pin 10 high. You're keeping it high for this amount of time. And the robot, the wheel is rolling, and then you're switching it low, and then you're pausing it for 20 milliseconds. So there's the robot, there's the wheel spinning. Let's change this value to like 1600. And now we know that the wheel was rolling forwards, so the robot would actually move forward. And let's see, so I'm not going to press go here until we're out of here. So let's go back there. So now what I'm going to do is, while you guys are looking and girls are looking at this thing here, I'm going to hit the compile button, and we're going to see momentarily the robot will stop. Ah, that's interesting. The wheel is now turning backwards, and it's kind of slowish. So let's increase this value here to 2000 microseconds, and let's see what happens there. Ah, now it's still rolling backwards, but it's going fast. So let's change this value to 1000, and that's the high pulse that we were looking at. I'll talk about that in a minute. Now the wheel is going forwards, but very fast. You can hear the motors whining away nicely there. So what we're going to do now is we're just going to kind of save that, and we're going to switch off this thing here. We're going to go out of this screen there, and we go out of the, and there we are. So we're back here looking at this thing. Now, we put the robot up on the stand there, and there's some nice explanations here, and we've got these values here. And so delay microseconds, you see this is the code, this is the actual code, but we've got these values, and it says slow, medium, fast, and direction. So these values here, basically, you'll notice the middle value. So there's 1000 at the top, 2000 at the bottom, and there's values in between. But if you dial 1500 in, what do the motors do? They stop. So they stop, stop, stop. But if you dial these other values in, the motors go, just move that there, the motors go forwards or reverse, and slow, medium, fast, paced. So in this way, you can actually have complete control over those little motors on the robot by varying these pulses. So I thought what we should try and do is have a look, see what does this look like on an oscilloscope. So I've got this oscilloscope here, and I've got the robot over here, and I've got, this is the oscilloscope probe that is connecting to channel 1 on the oscilloscope. And what I'm going to do is I'm going to switch on the robot here, and you'll hear this wheel is running. So what you can see on the screen there now is you can see this is your low for 20 milliseconds, and that's your high. This is your time base. I'm just going to adjust that. So you can see you can increase and decrease the time base. And then this grid here on the oscilloscope, these are volts per division. And I disconnect this probe from the robot. I can actually connect, so this is a self-calibration port, and so we can put this probe into that hole there. That's your triggering control over there. This is your time base, and then there we can stop it, and this is your volts per division, and you've got your position. So I hope that this has been useful and instructive.